Hello guys, welcome back to my channel, and today I want us to start something new, right? I want us to start this series where I will be starting the whole junior certificate course all over again, and we might go on and advance onto the Leaving Cert course, but I want us to have a very strong foundation, because as you come on further into second year and into third year and fifth year, you just notice it's all the same things except it just gets more advanced. So which means that the foundations must be there, and everyone must have this strong foundation. So it's important that we have a strong foundation from first year. And some people maybe didn't get the privilege to get a good teacher in first year, or maybe just didn't pay attention, was a messer, or still getting used to the whole secondary school thing and wasn't paying attention in school. So maybe these cases might have happened. That's fine. I'm here to help, and I'll start off with the basics all over again. So I want us today to start off with the natural numbers. So the natural numbers, so let me just write that down. Natural numbers. Okay. So now the natural numbers are basically the counting numbers. So the numbers that we use to count everyday things. So how many books do I have in my bag? 1, 2, 3, 4, 5, 6. I have 6 books. So these are the counting numbers. They're just whole numbers, right, with no decimal values, not a fraction, just whole numbers, and they're positive. So it's 1, 2, 3, 4, 5, and on and on and on, and it never ends. So as long as the number, any number that fits that criteria, so like it's positive and it's whole, then it's a natural number. So now even natural numbers, they can be divided into categories. Okay. So natural numbers can be divided into 2 categories. So we can have even and odd numbers. We have even numbers and we have the odd numbers. They're all natural numbers. Actually, I forgot something here. 0 is not a natural number. And also the symbol that is used to show that something is a natural number, they just use capital N. Oops. Yeah, they just use capital N to show that this number is a natural number. Okay, so we see that there's 2 sets of natural numbers. There's the even numbers and the odd numbers. You probably know this from primary school, but I'll go into it anyways. So what is an even number? An even number is just any number that can be divided by 2 with no remainder. So let's say we have a number 4, and if we divided that by 2, we'll get 2 with no remainders. Or another way we can write this is 2 and 4. This goes into here twice and there's no remainders. But if let's say it was 5 divided by 2, how do we do that? So like this is an example of an even number. Okay, so 5 divided by 2, I'll just leave it blank for now. Well, I'll just put it in. It's 2.5. Okay, 2.5. Now 5 divided by 2 is 2.5. This 0.5 is a remainder, and I'll show you how. So if we use the same system, 2 into 5. So it doesn't go evenly. It goes in here twice, right? But there's one remainder, because 2 by 2 is 4, and there's still one remainder. So we'd have to put 0.0, and then we carry that 1 here, and we get 2 into 10, and we get 5. So there's a remainder there, and therefore this number is odd. Okay. So now, there's a concept in mathematics and everyday life. We use a word called consecutive. And what consecutive means is just numbers or anything that has a specific order and they follow each other. So like the days of the week, if we said Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, this is in order. But if I said Monday, Friday, Saturday, Sunday, this is not consecutive. It's not following any order, right? So I can say 6, 7, 8, and 9, for example, the numbers 6, 7, 8, 9. These are consecutive. They're following each other in the normal number line pattern, right? So 6, 7, 8, 9. But then I could also say 2, 4, 6, 8, and 10. This is also consecutive, but they're consecutive even natural numbers. So it's in a category, and within that category there's a system that it's following, or a pattern. So there's 2, 4, 6. So this is consecutive. It follows. It just adds on, right? Every time it just pluses 2, plus 2, plus 2. Okay. Now, in all of mathematics, right, in all of this sort of mathematics, we have something known as the number line, right? Okay. So now the number line is just the area, or it's sort of a simple way of depicting natural numbers, and it's just to put them in a horizontal line like this. So we can start off here with 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so what we notice with this here, right? We're in this system, in this specific number line, everything is adding by one, again and again and again. But it could vary from time to time. So like it could be some. Well, we'll go into that another time. So we see in this number line, it's going up in ones. So the thing about the number line is if you're adding a number, it's going to go that way in the number line. If you're subtracting, you're going to go that way in the number line. I will come back into this concept when you look at integers. Okay. So this is the number line, and each of these dots represents each of the numbers, right, on the number line itself. So, right, so there's something called place value. You probably remember hundreds, tens, and units in primary school. And this is the same concept in first year maths. And it's quite important. So we'll just look into that now. Okay. So for us, if you think about it, numbers are just symbols, right? So we have this number here, right? This number here. I haven't called out the number, but in your head, I'm sure you're already saying that that number is 10. It's because we just visualize and we see this is a symbol, and this symbol represents something. It has some sort of value to us. When we see 10, we see this number 1 and 0. Together, we see that this forms 10, right? So these are sort of just symbols that we use to represent numbers. And these are called numerals, okay? So in our number system, we can write any number, large or small, using the 10 numerals, okay? No matter how big the number is, it will always just have numerals, like the one from the numbers from 0 to 10, to 0 to 9. That's it, okay? So now the big advantage of this system is that the same numeral might have different values depending on the place it occupies in the number. So I'll show you what that means, okay? So let's have I'll just have a little diagram here, okay? So I'm gonna write two numbers here. So I have 3, 6, 8, and I have 4, 2, 7. Okay. So here, this section, I'll just divide these into sections here, just like that. Okay. Now, this first section here is the 10,000s. I'll just write 10,000s like that. I'll start off with here, the units. So the units just basically the one, like just the numbers on its own. And we have tens. We have the hundreds, and then we have the thousands. Just put it as TH. So what that actually means, so if we look at this number here, 368. By us reading this number, we read it out as 368. What that shows us here is that, okay, we have the units, so we have, okay, we'll start off with here, okay? So we know that there's a hundred because it follows this order. Units, tens, hundreds, thousands, 10,000, 100,000, on and on and on, okay? So we'll look at the thousand, we'll look at the hundreds first, okay? So we have 3 hundreds. What that means, we have 100 plus another 100 plus another 100, which means that we have 3 100s. So 3 hundreds. And then we have a 60. And 60 is the same thing as saying 6 tens, as you can see, 6 tens. So we can have 10 plus 10 plus 10 plus 10 plus 10 plus 10. 1, 2, 3, 4, 5, 6. Okay, we have 6 tens there. And we have 8 units. And a unit is basically just ones. So we have 8 ones. 1 plus 1 plus 1 plus 1 plus 1 plus 1. 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so we get the point, right? We just have a bunch of numbers like this. So if this same number, 368, could also be written like this. Okay, and even these tens can be written as ones. So it it's just easier to write this than to write this every time we want to write the number 368. So it's just very important that we notice that this is this is also the same thing as saying 300. So we have 300 and another way for writing and is plus, and 60. So 60 is this, 6 tens, and 68. So plus another 8. Okay. So that's the system that we use, and we had the other number 26427. So it's the same concept. So that means that we have two 10,000s. Okay, I'll just write sound for short, which is the same thing as saying 20,000, which will just write 20k. We can have 6,000s. 6,000s, okay, blah blah blah, and that's the same thing as saying 6k or 6,000. So we get, yeah, I'm sure you get the point. So the number 6, okay, so we had the chart, right? And the chart was 3, 6, 8. Okay, like that. Oh, well, it's probably better. I'll just redraw the numbers again. So we have 3, 6, 8. We had 4, 2, 7, and 6, 2. Okay, so we had this chart. So I'll just go like this. Okay, so we had the units. We just put units, tens, hundreds, thousands, and we had 10,000s. Okay, so we see the number 6 appears in both of the numbers. Here, the 6 is in the tens place, which means that there's 60. But here, the 6 is in the thousands, and it represents 6,000. So see, these are the same numbers. Both appears as 6, but the values of it are different. As you can see, 60 and 60,000. If someone were to give you 60 euro, or if someone were to give you 6,000 euro, obviously you would rather have the 6,000 euro. Okay? Okay, so now that we have the main concept of this diagram is known as the place value diagram. It's not really important what it's called, but you get the point, the fact that there is 6 here and 6 here. They have the same symbol, right? It's the same number, like 6 and 6, as you can see, but they both hold completely different values. So this is the concept that I want you to get and grasp for now. And if you can grasp this for now, then you can move on to the next video, and I will look into more examples and other things that we can do with natural numbers. Thank you very much. Bye bye.